Okay, here for example number 6, we're going to introduce slant asymptote. If you remember, if the top is bigger than the bottom, that means there's no horizontal asymptote, top bigger than bottom. Well, if the degree of the top is exactly 1 more than the degree of the bottom, such as we have here, x squared is exactly 1 more than x to the first, then the graph has a slant asymptote. To find it, we have to use long division. To find it, we have to use long division. So we're going to take the top, x squared minus x minus 2, divided by x minus 1. X goes into x squared 1x times. 1 times x is x squared. 1 times negative 1 is negative x. I'm going to subtract. They both cancel, bring down the negative 2. X does not go into negative 2, so this is the remainder. Well, the remainder does not matter. The equation is going to just simply be, or it's actually, if I can write plus negative 2 over x minus 1, but the remainder does not matter. The equation is simply going to be y equals x is the equation for that asymptote. So, to graph a line y equals x, 0, 0, up 1 over 1, up 1 over 1. And we have our slant asymptote looking something like that. Okay. Now let's go back to our very basic look for a whole, because it looks like the top factors. The x minus 2, x minus 1, or sorry, x plus 1 over x minus 1. Since nothing cancels on top or bottom, that means no whole. But for vertical, set the bottom equal to 0, x equals 1 is our vertical asymptote. And since it has a slant asymptote, we don't have to check for a horizontal because it's not going to have one, because the top was bigger than the bottom. So my vertical asymptote goes right there, x equals 1. And now to deal with this, I have to find some points. The points I would probably check are going to be out here to the left of the asymptote, so you can pick 0 and negative 1. Then to the right of the vertical asymptote again, 2 and 3. Pick those numbers for x, plug and chug. So if I put in 0, now you should be able to do plug and chug on your own or on a calculator. If you put in 0, you get 2. If you put in negative 1, you get 0. If you put in 2, you get 0. Put in 3, you get 2. Plot the points, 0, 2, negative 1, 0. That means this is going to look something like that. And then 2, 0, and then 3, 2, and this one's going to look like this on that side. Okay? I want you guys to go ahead and try number 51 on your own, and then press pause, and we'll come back and check it. 51 says h of x equals x squared over x minus 1. I notice there are no holes because the top is just x times x, nothing cancels. Vertical, x minus 1 is 0, so x equals 1. For horizontal, the top is greater than the bottom. That means there are no horizontal. But since it is bigger than the bottom by 1, top bigger than the bottom by 1, it does have a slant. And so I have to take the top of x squared divided by x minus 1. X squared divided by x is x. X times x is x squared, then minus 1x. Fill in with the 0x there. Subtract 0 minus negative 1 is 1x. 1x divided by x is going to be positive 1. 1 times x is 1x. 1 times negative 1. Positive 1 is my remainder. Because 0 minus negative 1 is positive 1. The remainder does not matter, so it's the equation y equals x plus 1 is my slant asymptote. So take a look at that. X is positive 1. I'm going to graph this using slope-intercept. Means to go up 1, put a dot, and then the slope is 1, so up 1, over 1, up 1, over 1. And my slant asymptote is the equation of the line y equals x plus 1. If you forget how to graph that with slope-intercept, just make a t-chart, 0, 1, 2, solve it, and graph the points. Okay, now to find the other points. My vertical asymptote is at 1, so 2 points to the right would be 2 and 3. 2 points to the left would be 0 and -1. Plug and chug, put the points in, whatever you gotta do, and you should come up with 0, 0, -1, -1/2. For 2 you should get 4, and for 3 we get 4.5 or 4.5. Plot the points, 0, 0, -1, -1/2. So this one's going to be kind of tricky, but it's going to look like this. And then 2, 4, 2, 4, and then 3, 4.5. This one's going to come down into here and look like that, number 51. Whoa.